And welcome to Excel to Civil 3D, creating quantity sheets in Civil 3D. My name is Mitch Lavin from the Wisconsin Department of Transportation Methods Development Unit. Now, there are many ways to create quantities plan sheets for Wisconsin DOT plans, but this class we're going to cover two preferred methods to take tables that come from Excel and convert them into quantity sheets in Civil 3D. I've been with the Wisconsin DOT for about 11 years now. I first started out at the North Central region in Rhinelander as a design and construction engineer. I used Civil 3D in multiple design projects through my career at the North Central region, ranging in simple rehab to full reconstruction. I also use it in construction as well for quantities calculations and so on and so forth. I was there for 6 years, and after my time in the North Central region, I moved to Central Office, or the Bureau of Project Development, in the Methods Development Unit. I've been with MDU for 5 years, working on Civil 3D training, support, standards development, and anything that goes to implementing Civil 3D for Wisconsin DOT use. Today we're going to talk about taking Excel quantity tables and converting them into Civil 3D plan sheets. We're going to review the standard files that WisDOT produces to create these quantities plan sheets in Civil 3D. We're going to learn about the method of pasting links from Excel tables to Civil 3D, and then we're also going to learn about and understand the method of utilizing Excel named ranges, Civil 3D data links, and Civil 3D tables to create quantity sheets in Civil 3D. In this session, we're going to cover two methods to create quantities plan sheets using quantities tables from Excel. These two methods are the paste link method and the data link method. The paste link method essentially pastes a live image of the copied Excel table in Civil 3D model space that is linked back to the Excel file for live updates every time the Excel file is saved. We'll select the range of cells we want to be shown in the Civil 3D file, right-click copy, and then in Civil 3D we'll go to paste, paste special, and paste that link to the Excel file into the Civil 3D model space. The data link method is a new workflow that was developed after there was a request to create miscellaneous quantities plan sheets with searchable text in the final PDF. The paste link method, as we previously discussed, does not produce searchable text in the PDF. The data link method essentially provides a link for the data and formatting in Excel and the range of cells that we choose to be consumed by Civil 3D. The data and formatting is then used to create an AutoCAD table in Civil 3D to display that data and formatting. First, we'll select the range of cells we want to create the table from. Using the WisDOT Excel add-in, we'll use a tool named DataLink Named Range to create the named range for that specific range of cells. In Civil 3D, we'll then use the custom tool Create Data Links and Tables to create data links for the tables, and then we'll go and actually create the tables in Civil 3D model space using the same tool. The WisDOT Civil 3D Knowledge Base, or WisDOT Civil 3D training website, contains a few topics relative to this discussion. We have a few workflow topics, one regarding earthwork quantity sheets. We can find that in the plan production area of the Civil 3D Knowledge Base. This one covers both the Civil 3D data link method and the paste link method. Similarly, we have a workflow for miscellaneous quantity sheets in the plan production area. And these both also use the WisDOT data link method and the paste special paste link method. In the WisDOT Civil 3D State Kit, there are two sheet templates that allow quick and easy creation of quantities files. They are located in the templates and the sheets folder, and they're easily identified by the discipline of the plan sheets, 03 MQ speed sheet and 09 earthwork speed sheet. To easily access these templates while in Civil 3D, the WisDOT Civil 3D package provides a palette for each discipline of plan sheets, including a palette for 03 miscellaneous quantities and 09 earthwork quantities. We can see them here. At this time, these palettes only provide a quick link to create a new quantities drawing from the templates that we talked about earlier. The button 03 miscellaneous quantity speed sheet creates a new drawing file using the 03 MQ speed sheet template. Similarly, the palette button earthwork data speed sheet creates a new drawing file using the 09 EW speed sheet template. Using the Civil 3D data link method requires a Civil 3D table style. WisDOT provides a table style named WisDOT standard for usage when creating miscellaneous quantities and earthwork quantities sheets using the Civil 3D data link method. Each of the quantities templates contain this table style by default, and it is the default template. If we check into some Excel requirements before we actually get into going through the demo, it is best practice to store the Excel quantities files within the Civil 3D project to allow for Civil 3D to maintain a relative path within the Civil 3D project. If we store these quantities files on other locations like a network drive or box or other cloud storage, we're not going to have a relative path with respect to the Civil 3D project and the Civil 3D sheets files. By default, the custom WisDOT tools such as Q2P or the WisDOT earthwork reports automatically follow the formatting requirements that we feel are best practices. But if you have a custom quantities file, it is recommended that the font size or the font being used is Calibri Light to match the rest of the plan, and that we use the size of 8. Then we do not want to see the grid lines within the quantities table, so it's recommended to go to the View tab within Excel, Show Panel, uncheck grid lines. And then if you ever see those little triangles in the top left-hand corner of cells, those will come through if we use the paste link method. So it's best to turn those off by going through the File Options, Formula tab, Error Checking Rules, and uncheck those rules. Another Excel requirement is merge and center. Cells that contain text that is too large to fit within a cell must be expanded or allowed to fit in more cells. Use the merge and center command followed by left align to merge multiple cells and allow the text to fit within one single cell. We can see here initially stations and offsets are to center of the structure are too wide for that single cell. We use merge and center to include that text within multiple cells. And this is very important for the data link method, because if we have the text too wide for a single cell, that column may get too large for the plan sheet. We'll have to do some adjusting, and the text will then wrap if we narrow that column up. So it's good to merge and center that text to be fitting in multiple cells. And then specifically for earthwork and the WisDOT earthwork report, there's a few things we need to do to get it prepared for the earthwork data sheets and the earthwork summary. The first thing we need to do is delete the columns that contain all zeros. So we'll jump into Excel here. And when we run the WisDOT earthwork report, there's some materials that might not be accounted for. For instance, we might not have marsh, we might not have a rock. And for instance, in this data set, I know we have marsh. If we scroll down, there is some marsh lower down, but I know that we do not have rock. So I can delete these columns from the earthwork detail report and the earthwork summary. Just to note, this is only really applicable for the earthwork reports that are created with the WisDOT tools after August 31st of 2022 using Civil 3D 2022. Any earthwork reports created before that, you cannot delete columns. There's not an error trap in the column equations to account for those deleted columns. You have to, if you're using the paste link method, you'll have to right-click hide those columns. If you're using the Civil 3D data link method, you'll have to actually unmerge the cell, and then to maintain the equations, you need to move them out of the way. Move them off to the side like this. The equations are maintained, and then delete those columns. I'm going to undo that stuff, but I'm going to delete these columns that I don't need. So I'm going to select the rock and EBS columns. Rock, EBS, EBS. I don't have marsh. Right click, delete. And we can see the columns are maintained. We do that for all of the detail sheets. If we go to the earthwork summary, we can see that there's range not found. I know I don't have EBS, rock, EBS, like that. I can delete those columns. And then if you see in cases where you see a range not found, the range isn't found because I deleted that data from the earthwork data details sheets, but I can change these to 0 because that's really what they are. This is the range not found, just there for designer just to understand what's going on. One last thing we need to do is for the earthwork detail sheets that have a long list of details. Typically, you can only fit so many details or list of details on one plan sheet in the PDF. And in using the data link method, it's kind of figured out to be about 45 rows, probably about the same for the paste link method. But WisDOT has developed a tool that we can easily duplicate this header on multiple sheets. And that tool is located in the WisDOT Excel add-in. Basically, this will be out in the next update, so keep an eye out for that. We'll select the range of cells we want to duplicate and click on, we can specify how many rows we want of data in between. So 45 rows, click on repeat selection every 45 rows, and it'll go through and duplicate that header every 45 rows. And now we have our data split up for all the different sheets we want to utilize. There's manual ways to do this, but if you get the WisDOT Excel add-in, you can easily do that very quickly. All right, so let's jump into the demo of both of these methods. First, we're going to start with the paste link method, which we discussed earlier. It relies on copying the cells in Excel and pasting a link to the cells, basically pasting an object or a picture of those cells in Civil 3D. The content that we see in Civil 3D automatically updates when the Excel file is saved, and the final output in Civil 3D is actually an OLE object, or object linking in and embedding object, and it's actually published as an image in the final PDF. The downside of this being an image is that text is not searchable. One thing that we came across here in recent months, probably the last year or so, is there is an issue that surfaces every now and then for people trying to open an existing DWG that contains these links. And the issue is when you go to open it, Civil 3D just kind of hangs, doesn't do anything, and you get a error message that says Microsoft Excel is waiting for another application to complete an OLE action. And for some reason we could not figure out what was going on, but we did find out that at least at WisDOT we have Bluebeam on our computers. Most computers have Bluebeam, and with Bluebeam comes an Excel add-in. And unfortunately, the Bluebeam Office Excel add-in is causing this problem, so it seems, because once we disable that add-in, the problem goes away. The file is allowed to open. The Civil 3D file that is linking to the Excel file automatically opens or instantly opens once you go to try to open it, instead of going through the issues that we see above. So go into the COB add-ins in Excel, disable the Bluebeam Office add-in, hit OK, close Excel, open the DWG, and you should be good to go. Some pros of the paste link method: the final tables in Civil 3D contain the exact formatting as we designed it in Excel. So if we put a line or put a certain text in a spot or a border on a cell, we're going to see that in the final output in the PDF. It's relatively straightforward to create the link, copy, paste link, there it is, and changes to these tables in Excel automatically update in Civil 3D once the Excel file is saved. Cons: the text in the PDF output is not searchable because it's essentially an image of that cell, range of cells in Excel. Changes to the table size: so for instance, if we add a row or a column within the range of cells, require a complete deletion of the table and repasting of the table, select, copy, paste in Civil 3D. And then we also know about this known issue with the Civil 3D files not opening due to the Microsoft Excel OLE action issue. So now we can actually go into creating the files and going through the process of doing the paste link method. First, we need to review the FDM for file naming conventions. We can see the link here, and I know what they are, so I'll just do it the way it is. We have it in the handout as well with what the file's name should be named. And for earthwork, you need to have a complete earthwork quantities report already done. And then for instructions on that, we can go to the Civil 3D knowledge base. So I'm going to create a miscellaneous quantities file, but I do have instructions on how to create the earthwork file as well. So I'm going to jump into Civil 3D, move this off to the side, jump into Civil 3D, and we'll create our initial quantities file. From the WisDOT Sheets tab, we can see the sheet creation panel and palettes. I'm going to go into the 03 quantity palette. Once that loads, I'm going to create a new DWG using the 03 miscellaneous quantities speed sheet palette button. And that's going to create a new DWG. We'll close the DWG2 because I don't need that one. And this is our speed sheet. We'll save the drawing in our Civil 3D project. And the standard naming convention is 030201-MQ. And hit enter to save it. So once we have that DWG created, we can go back into our Excel spreadsheet. So I'm going to go into my Q2P Excel spreadsheet, which contains all of my different quantities tables. You can also do that with the earthwork. We have our earthwork one here as well. I'll get that available if we need it. So the first step in creating the pasted link is to select our range of cells that we want to show in Civil 3D. We'll click copy from the contextual ribbon or the ribbon, and then go into Civil 3D, Home tab, paste, paste special, paste link, OK, and we'll place that in our location. Go back to Excel, go to the next page. Select the range of cells, copy, Civil 3D, paste, paste special, paste link, and we'll place it there. We'll keep doing this. We'll go into the earthwork because we'll typically want to put the earthwork summary in the miscellaneous quantities. So I'll select the earthwork summary, copy, and we'll put that in its own page, paste, paste special, paste link. And it's too wide, so I'll have to go and modify this and narrow up the columns. There we go, hit save. Go check it in Civil 3D and it updates automatically. So that was good exercise to see that how fast it automatically updates. And it's simple as that, just going through and selecting a range of cells that we want, copy, paste, paste special, paste link, OK, and put it where we need it in our Civil 3D drawing. We can see that if we go to the layouts, that those guys show up. We do see a border around the outside, but keep in mind it's set up that the border does not print. You will not see that border once we print this to a PDF. We can see that here if we go to plot, preview, the border is missing. All right, let's review a finished version of this drawing. So I'm going to go into my open, paste link method here. And we can see I've got them kind of organized. I put some lines down to separate them out to make them look nice. And there we go. That's the paste link method. Pretty straightforward. One thing that we need to do is add these layouts to the sheet set manager. So if I've got 9 layouts here, we'll go into the sheet set manager. We'll open our sheet set, and then we can import those layouts into our miscellaneous quantities. Right click, import layout as sheet, navigate to our miscellaneous quantities file, and then figure out whichever ones we want to bring in. We can do a shift select to select as many as we want, deselect the ones we don't want, and then select the ones we want, import checked, and then those will come in from that file. And that's pretty much the basics of the paste link method. We can go and check a PDF output quick. So we can see we have the tables in here, but if I go and try to select, I can select this text down here. I can't select that text. No, here we go. That's the right one. I can select this text down here because it's actual text, but I cannot go and select any of the text here. If I go and do a find for, let's say, project, it'll find that project text on the bottom there. But if I look for something like clearing, which would be typical for a project, it does not find that text. So that's the only downside with this method, is that, or one of the downsides, I guess, that the text is not searchable in the PDF. But that's the basics of the paste link method. Copy it from Excel, paste link in Civil 3D, and links up the update when changes are made and saved in Excel. Some issues with adjusting the range of the cells that you see, but that's pretty much it. Now we can talk about the Civil 3D data link method to create quantities plan sheets in Civil 3D. The following workflow will utilize Excel name ranges, which are essentially a range of cells that are named in Excel. Then we'll link that named range to Civil 3D utilizing Civil 3D data links. And then we'll utilize a custom Civil 3D table style to stylize and place quantities tables in a Civil 3D plan sheet. The pros of this workflow is the output of the PDF is a searchable text. So if there's a specific bid item we want to search for, we can just use Control F in the PDF to search for that text. And then also, if there's any table size changes, so if we add a couple columns to a particular quantities table or delete a column or add rows, we easily can update that named range utilizing the WisDOT named range tool. And since the data link only looks at the named range in Civil 3D, those changes will automatically be consumed in the Civil 3D drawing. One con that we can think of is it seems like it takes a few more steps to create these links and takes a bit more time. But the time is saved by not having to recreate these links. To create the quantities tables in a Civil 3D, a named range is required in the quantities table in Excel. So each table that we want to create in Civil 3D or have a displayed in Civil 3D needs to have its own named range. This allows a link to be created between each individual table in the Excel file and the table that's being built in the Civil 3D drawing. The following workflow utilizes a custom WisDOT tool to create these named ranges, more out of a necessity for speed than Excel. Excel does provide a native tool to do this, but it takes a lot more time to do it. So we're going to utilize the WisDOT Excel add-in and the data link named range tool. For external partners, this tool is available on the WisDOT Roadway Design Files website. We can see that add-in here for either 64-bit Office install or 32-bit Office install. For internal DOT staff, you should see it if you have Civil 3D installed. You should see it in the Software Center. If you don't, contact IT to get it installed. Complete tool documentation is on our Civil 3D knowledge base. So it's pretty straightforward. Let's go jump right into the demo of this workflow. So let's jump over into Excel. Here we are in the miscellaneous quantities Q2P Excel spreadsheet. The basics of the way this tool is going to operate, we're going to go to the WisDOT Civil 3D Excel add-in, and basically what we're going to do is select a range of cells that we want the table to be made from, and click on the data link named range. And what's going to happen is it's going to create a named range with the naming convention of DL underscore sheet name. So it's going to utilize the sheet name, for instance, this one is 201.0105 clearing and grubbing. It's going to utilize that named range, or that sheet name, to create a named range. Now this is very important because the named ranges have a very specific allowable characters that can be used in the named range. For instance, we can only use letters, numbers, periods, and underscore characters in a named range name. So if there's anything else that doesn't meet those type of characters, it's going to throw an error. So for instance, if I have a dash in my name down here, and I go make a named range for this, it's going to throw named range could not be created, likely due to an illegal character in the sheet name. So native Excel, you would not be able to create a named range with a dash anyways. So it's very important to go through your tabs or your sheet names and make sure there are no illegal characters in the sheet name. Only use letters, numbers, periods, or underscores. Now, if you have spaces, that's okay. The data link name range tool is going to replace the spaces with underscore characters. So what I'm going to do is select my range of cells and click on data link named range. We can see that there is no data links or named ranges in this drawing yet, or for these data links. If I clicked on data link name range, it created a named range for clearing and grubbing based on the sheet name. Go to this tab, data link name range, and just go down the line and create data link named ranges for each range of cells we want to create. I'm going to jump over into earthwork to show a couple more things. I've got a drawing that is pretty much formatted, ready to go into the final earthwork data plan sheets. We need to create named ranges for the notes. We need to create named ranges for the different series of cells. So first, on this particular case, I'm just going to create I'm going to call it like a dummy named range, so I can create a custom name for that named range. The way this tool works, if we create a named range for, let's just say, cell A1, that's going to make its first named range there. But then I want to go create a named range for these notes over on this side. If I click data link named range, typically it would want to use the sheet name, but because we already did that with the dummy cell A1 up here in the top left hand corner, it's going to ask us, do we want to overwrite that named range, or do we want to add a custom name into this? In this case, because we're going to have multiple named ranges on this particular worksheet, we want to have a custom name. So that's why I went and created the dummy name on the top left hand corner, because I want to have custom names for all the ones that actually make sense on this particular worksheet. So in this case, I want to do underscore notes because I know this is the notes I want to use on my earthwork data sheets. And then I can go down and select my range of cells, my 45 cells here, data link name range, and then I could do like an underscore one, sheet one, and just keep working my way down. Sheet two, underscore two, and just repeat that all the way down. Then this can be repeated across to the other detail sheets, data link name range for Clade, because I'm going to reuse the notes from the first one, so I don't need to remake the notes on this one. And ramp D, ramp C, ramp B. We'll just do them all right away while I'm in here. And the last one we want to do is the earthwork summary. So I can select this. Typically we can get all of this on one sheet in the plan set. So I'll just utilize this whole range selection here. Data link named range, earthwork summary. It's good to go. We'll save the Excel file. And now we can review, like for instance on my Q2P, I can see all of the named ranges that I have over here. So this is one that's finished already. And we can see I have many different named ranges for each one. What's nice about Excel now that you have the named range, you can use this kind of like a quick go-to. Click on that named range and go right to that particular one, HMA Terrace. So there we go. We can jump right to it. And that's the basics in Excel. You really only need to have a named range for each table that you want to be displaying in Civil 3D. Speaking of Civil 3D, now that we have DWG or Excel files that have all these named ranges for the different tables that we want, we can go over into Civil 3D and make the data links. All right, let's jump over into Civil 3D then. Now I have a blank DWG open. We cannot use this blank DWG for quantities sheets. It's not the best practice. What I'm going to do is utilize the WisDOT sheet palette for earthwork or miscellaneous quantities to create a quantities sheet DWG from the speed sheet templates. I'm going to do earthwork this time around, so I'm going to click on the 09 earthwork palette. And when that opens, I'm going to click on earthwork data speed sheet to create the speed sheet drawing that contains all the layouts and the layouts, or the view frames and the layouts for 20 different quantity sheets. I'm going to close drawing 7 because I don't need that one anymore. And we'll save this DWG in this Civil 3D project under Sheets Plan or Sheets, and then we'll save it 090101-EW. And I'm just going to put a suffix at the end for this one being ACEC, just so I know. Hit save, and we're ready to go. So once the named ranges are created in the Excel workbooks, we need to create the data links that'll connect the workbooks or the Excel files to the Civil 3D file. To do that, we're going to utilize the custom tool that WisDOT has developed called Create Data Links and Tables. This tool is available on the WisDOT Sheets tab in the ribbon. Sheet Tools drop down, Create Data Links and Tables. If you need more information about this tool, just hold over the name, click F1, and the F1 help file for this tool will come open. So we'll create data links and tables. And the first step of the process is to actually create the data links. That's going to link between the Excel file and the DWG. So we'll go click and select the Excel file we want to link to. So I'll click on this File Open button. We'll navigate to our Civil 3D project and the location of the earthwork file. There we go. And here's our earthwork file, earthwork 8. Click open. And it's going to load all of the named ranges that are in that file. Now with our earthwork reports, there's a lot of named ranges in there. So it's the easiest way to find them, because we know that the naming convention for the data link or the named ranges that are in Excel start with DL. We can just type DL and then wildcard asterisk, whatever you want to call it. And we can see all the data links in that particular Excel file. We know DL8 is that dummy named range that we created, so we don't need to select that one. But otherwise, I'm going to go and select the rest of them. I'm going to do a shift select to get all of the ones that I want. We got all of the ones from Highway 8, the notes, Gatewood, Clade, Ramp, A, B, C, and D. And then you could do select all or deselect all. There's buttons available there too. We want to choose relative path. Relative is always the best. And then leave the settings as is, allow writing and use the Excel formatting. Click OK and watch for a process complete. We can verify that these are available, and this is a Moldus dialog box, so I can slide it over and still have access to all the everything else in Civil 3D. If we click on, go to the Annotate tab, Tables, and click on Link or Link Data right there in front of me. Now we can see all of these data links have been created. Basically automates the process in the data link manager. Now we can create the tables. Now let's say if we want to create more data links for other DWGs or other Excel files, all we gotta do is go and select the new file that we want. Just pretending if we want to do miscellaneous quantities, we can select that file, click open. The filter remains, so it automatically filters to the DL. And now we can actually go create data links for these different tables as well from a different file, and those would be available here as well. So if we're doing a miscellaneous quantities file, that's nice because we can have as many files as we want being consumed in here through data links. We'll create a table for the earthwork, and here there's a couple of ways we can go through this process. We can do one at a time. We can do multiples at once by doing shift select or select all. The biggest thing that we need to understand here is what it's actually doing. I'll do the first one just to kind of talk while it's doing it. So I'll select the first table. We'll choose the table style, WisDOT standard, which is default in both of the earthwork data sheets and the miscellaneous quantities template. Click OK. And I'm going to digitize the location in the top left corner of the table. And what it's actually doing, it's going and reading the data from the original table, the named range in the Excel file, and it's taking that data and not actually like copying it. It's going to take that data and formatting and build a completely separate AutoCAD table. They're still linked. The AutoCAD table is still linked to it, but it's an AutoCAD table in Civil 3D. It's not like a replica or an image of the table in Excel. It's an AutoCAD table. The process is complete. So I'm going to slide that off to the side. So now we can actually see this is a table. I can go into the cells, and you can actually edit these cells from in here. I wouldn't recommend it. It's probably better just go back in Excel and edit them there. You can edit them here and then write it back to Excel, but it just seems to be a little bit better if we edit them in the Excel file instead of editing them in Civil 3D. We can select the table, and there's a bunch of grips that come up. You can adjust column widths. It's going to be, we've minimized the boundaries or the size of the cells, but so they're pretty much minimum size as we can get them automatically. You can adjust the overall size of the table by using this grip here, and it's always good to kind of just adjust it anyways, just to get it to fit a little bit better on the sheet. There we go. I'm going to bring my table back over here. I'm going to create a notes table. Click OK. And we'll drop that down here because we want a notes table on each of the pages. So we'll get this placed in a good spot. We'll need to narrow this up a little bit. Move it around to get it centered on the bottom. And then we can copy that note to the rest of the layouts. Kind of like this. That's how we're going to build that. And then I'm going to do a left to right select just to get those notes tables, and then copy them down to any remaining layouts if we're going to use them. So I'm going to demonstrate also, if you noticed when I built that first one, it took a little bit of time, maybe 10, 15, 20 seconds for that table to actually build, because it is consuming that data from Excel, and it's building a completely separate AutoCAD table while it's still linked. It's an AutoCAD table that's still, the Civil 3D's got to consume the data and build it. So I'm going to warn you, if you choose to go and build all of the tables in one swoop, it's going to take some time, a couple minutes, 10, 15, 20 minutes, because it's got to go through and cache all that data and build individual tables. So I'm going to do maybe just 2 of them here and see what happens. So when I do, let's do 3 of them. When I do 3 of them, what it's going to do is not going to just automatically place them in a place you want them. You're going to digitize one location, and then it's going to place those tables in a row as it builds it. So it's going to place a table, put a little space, and then place the next one, so on and so forth. So I'll do 3 of them just to demonstrate that here. And because we're going virtual here, I'm going to pause the video, and when it's done, I'll come back and show you what happens. So it's going to take a little bit of time. Note the time on the bottom left. It's 2:16 p.m. right now, and we'll see when they're done. What we can see is it's building the table. There's a status bar, so you can see the status of the progress of building those tables. So it just says building tables, please wait. All right, it's been about 2 minutes, so almost 3 minutes, just turned 2:19. So about 3 minutes to build 3 tables, so 45, 50 seconds a piece. So that's just what's got to be expected. It's just inherent to this process. It takes that long to build the tables. If we weren't using our tool either, if you're building these tables using Civil 3D tools, it's just got to consume that data from the Excel file and builds it here in Civil 3D. So if you want to do a group of tables, it might be best to do it and you go take a 15-minute walk and come back and they're ready. So once they're in model space, we can select them, click on the grip, and go move them into place. And we can see that there's a couple issues with them automatically being placed. You can see some of the text is overlapping, and this is easily fixed by just grabbing the grip on the table and just moving around to get it to open up a little bit. And what I usually do is kind of just grab it and then grip it as far up as we can, just to minimize the row heights, but also gets them all the text to fit. And you only have to do this one time. So whenever you're moving around and getting them placed, you just gotta do that one time. And then if there's any updates later on, those changes to the table size will stay, which is nice. All right, let's go jump over into a full completed miscellaneous quantities data link file. And let's just go over just the changes and modifications we can make to the tables in Civil 3D, and then also changes that happen to the Excel file and how we can consume those changes in Civil 3D. The basic tables, there's many different grips we can go into and adjust. We select table from the outside and just select it. We can get grips for each of the rows or columns. We can adjust the column widths individually. We can see automatic wrapping if we choose so. There's also grips that adjust overall table width here, like so. Down on the bottom, there's a triangle grip here that'll adjust the table height. And then you can also use the bottom grip on the bottom right to adjust the overall table size and bring it up as far as we can, just like that. It's a good practice if you're moving around, just grab that grip and adjust your width, but then also have the grip as high as possible because that'll shrink it to the minimal size vertically. If you select on a cell, we can see there's more grips that come up. You can adjust the width of the column with that grip. You can adjust the height of the row with that grip, so on and so forth. So those are some things we can do with just the grips in the individual cells. So now what happens if we make any changes to these miscellaneous quantities tables or earthwork tables or any of it? Again, this workflow works for both types of quantity sheets. Let's go over in Excel and just demonstrate what we do to make these changes and updates. So I'm going to go to a table that I don't know I'm working on. I'm just going to add some text I know is going to be very apparent, the changes. ACEC. We'll just put that right there. We'll hit save. And we'll go back into Civil 3D. If we close this DWG, save and close it. If we go reopen it, we can see those changes are not automatically consumed. If we had automatic consumption of changes to tables and on every Civil 3D drawing open, the drawing would take forever to open. We need to manually initiate these table updates. A couple ways to do that. There's some tools in Civil 3D that allow us to download and rebuild the tables from the original sources. From the Annotate tab, Tables panel, there's a button for Download from Source. If we select that button, now we can go and select the objects that we want to update. So I'm going to select that one table, or we could do a specific data link, or we can do all data links. It doesn't matter. I would recommend doing all data links, before a PDF publish, or if it's been a while since you did that, just to make sure you capture all the changes from all the different Excel files. Hit enter, and now we see that those changes are available. What if we change the size of the table? So let's go back in the Excel file. What if we, for some reason, we know we need to get some data out here. Now we need this area to be part of the data link or the table in Civil 3D. Well, all we need to simply do is just update the named range. Go back into the WisDOT Civil 3D add-in, data link name range. We'll overwrite the name range and rename it, or it's going to maintain the same name. Just overwriting it. Now the name range is this from A1 to D10. We save the Excel file, go back in. Another way to update this table, we can select the table, right click, and choose Update Data Links. And once that's finished, we can see that now the table has been rebuilt to the different size. We can adjust the location of it, adjust the size, whatever we need to do. And what if we need to do it again? We can go back into there and just update that data link name range. Okay, hit save. And the last way to update it, we can select a cell from the contextual ribbon, download from source, and the table updates to what we assigned it in the DWG. So it's fairly simple just to make those changes to the named range, and Civil 3D will consume that name range through the data link. And that's the best reason why we want to have name ranges in Excel, because those changes are automatically consumed when we have that data link looking at that named range. Now you may also notice that in the Excel file, we do not have our grid lines turned on. We have them turned off from the View tab, grid lines turn off. But here in Civil 3D, on these AutoCAD tables, we do see grid lines. The reason for that is that what we are looking at in these grid lines is actually the AutoCAD grid line. If we go into the plan sheet, we can still see them here, but if we go to Print Preview, Plot Preview, we do not see those grid lines. Now, if you want to do the WYSIWYG where what you see is what you get, you can turn these grid lines off. Go to the Home tab, Layers panel, Def Points layer, freeze that layer, and now we can see that we do not have any of the grid lines. But we do pull in the formatting from the Excel file. If we go and double check a PDF, the benefit of this workflow is that our text is going to be searchable. So if I do the text selection tool here, I know I can select the tables or the title bars, but I can also go and select the text. In here, the text is actually embedded, as they're not images like the paste link method is. So if I'm looking for, let's say, milling, I can type milling, hit search, and now it's going to go and search milling. Now what if I'm looking for a certain bid item? Let's say 204.0110. Hit search, and it's going to take us right to that spot. So that's the benefit of this method for your final PDF. It's going to be searchable, which is good for working in the field and other items possibly in construction or in design. So those are the two processes we could use to effectively create quantities plan sheets utilizing quantities tables that are sourced in Excel and linking them to the Civil 3D drawing and provide automatic updates. There's two options. Again, the paste link method, which utilizes copy paste, or we have the Civil 3D data link method, which utilizes a named range in Excel, a data link from Excel to Civil 3D, and a AutoCAD table to produce tables within the PDF. So with that, are there any questions on the process or anything else? And don't forget to go check out the Civil 3D knowledge base for these topics. There's a lot of information out there. And if you have any follow-up on or have any questions on the process, it's very detailed in the training on the Civil 3D knowledge base and also in the handout. So thank you very much.